Reflection of light for class 10th. If you are not subscribed my channel, firstly subscribe my channel Genius Zone and gets more updates. Introduction. Light rays basically consist of electromagnetic waves which do not require any material medium, like solid, liquid or gas, for their propagation. Speed of light waves depends on the medium through which they pass, as speed of light in air is slightly less than the speed of light in vacuum, 3 times 10 raised to power 8 meters per second. Same way speed of light in water and glass is much less than that in air. When light falls on the surface of an object, it can either be absorbed. If an object absorbs all the light falling on it, then it will appear perfectly black, for example a blackboard. Transmitted. An object is said to transmit light if it allows light to pass through itself, and such objects are transparent. Reflected. If an object sends back light rays falling on its surface, then it is said to have reflected the light. Luminous object and non-luminous object. Light is a form of energy due to which we are able to see the objects which emits light. For example, objects like sun, lamp, candle emits light of their own, and thus they are known as luminous objects. There are objects like table, chair, etc. which are non-luminous objects, and still we are able to see them, and this happens because they reflect lights which falls on them from a luminous object like sun, lamp, etc. and when this reflected light reaches our eyes, we are able to see such non-luminous objects. Reflection of light. The process of sending back light rays which falls on the surface of an object is called reflection of light. Silver metal is one of the best reflectors of light. Mirrors we use on our dressing tables in our home are plain mirrors. A ray of light is the straight line along which the light traveled, and a bundle of light rays is called a beam of light. Types of reflection: 1. Regular or specular reflection. 2. Diffuse or irregular reflection. Laws of reflection of light. 1. The angle of incidence is equal to the angle of reflection, and 2. The incident ray, the reflected ray, and the normal to the mirror at the point of incidence all lie in the same plane. These laws of reflection are applicable to all types of reflecting surfaces, including spherical surfaces. Real and virtual images. An image is formed when the light rays coming from an object meet at a point after reflection from a mirror, or refraction from a lens. The images are of 2 types. 1. Real images. Real images are formed when rays of light that comes from an object, or source, meets at a point after reflection from a mirror, or refraction from a lens. Real images can be formed on a screen and can be seen with the eyes. 2. Virtual images. Virtual image is an image in which the outgoing rays from an object do not meet at a point. It will appear to meet at a point in or behind the optical device, that is, a mirror, but they do not actually meet after reflection from a mirror, or refraction from a lens. A plane mirror always forms virtual images. Characteristics of images formed by plane mirrors. A. Images formed by mirrors are always virtual and direct. B. Size of image is always equal to the size of the object and the image is laterally inverted. C. The images formed by the plane mirror are as far behind the mirror as the object in front of the mirror. Lateral inversion. If an object is placed in front of the mirror, then the right side of the object appears to be the left side, and left side of the object appears to be the right side of this image. This change of sides of an object and its mirror image is called lateral inversion. Example, used in ambulance. Spherical mirrors. The reflecting surface of a spherical mirror may be curved inwards or outwards. Spherical mirrors are of 2 types. 1. Concave mirror. In a concave mirror, reflection of light takes place at the concave surface or bent-in surface. 2. Convex mirror. In a convex mirror, reflection of light takes place at the convex surface or bent-out surface. Important definitions. Center of curvature. The reflecting surface of a spherical mirror forms a part of a sphere. This sphere has a center. This point is called the center of curvature of the spherical mirror. It is represented by the letter C. Please note that the center of curvature is not a part of the mirror. It lies outside its reflecting surface. The center of curvature of a concave mirror lies in front of it. However, it lies behind the mirror in case of a convex mirror as shown in the figure. Radius of curvature. The radius of the sphere of which the reflecting surface of a spherical mirror forms a part is called the radius of curvature of the mirror. It is represented by the letter R. Pole. The center of a spherical mirror is called its pole and is represented by letter P as can be seen in figure. Principal axis, straight line passing through the pole and the center of curvature of a spherical mirror is called principal axis of the mirror. Aperture of the mirror, portion of the mirror from which reflection of light actually takes place is called the aperture of the mirror. Aperture of the mirror actually represents the size of the mirror. Principal focus and focal length of a spherical mirrors. A number of rays parallel to the principal axis are falling on a concave mirror. If the reflected rays, all intersecting at a point F on the principal axis of the mirror, this point is called the principal focus of the concave mirror. In case of convex mirror, rays get reflected at the reflecting surface of the mirror and these reflected rays appear to come from point F on the principal axis and this point F is called principal focus of convex mirror. Focal length. The distance between the pole and the principal focus of a spherical mirror is called the focal length. It is represented by the letter F. There is a relationship between the radius of curvature R and focal length F of a spherical mirror and is given by R equals 2F, which means that the principal focus of a spherical mirror lies midway between the pole and center of curvature. Image formation by spherical mirrors. The nature, position and size of the image formed by a concave mirror depend on the position of the object in relation to points P, F and C. The image formed can be real as well as virtual depending on the positions of the object. The image is either magnified, reduced or has the same size, depending on the position of the object. Rules for obtaining images formed by spherical mirrors. Rule 1. A ray of light which is parallel to the principal axis of the mirror passes through its focus after reflection from the mirror. Light rays passes through principal focus in case of concave mirrors and appears to diverge from principal focus in case of concave mirror. Rule 2. A ray of light passing through the center of curvature of the concave mirror or directed in the direction of the center of curvature of a convex mirror is reflected back along the same path as shown below in the figure. Rule 3. A ray passing through principal focus of a concave mirror or a ray which is directed towards the principal focus of a convex mirror becomes parallel to the principal axis after reflection and is shown below in the figure. Rule 4. A ray incident obliquely to the principal axis, towards a point P, pole of the mirror, on the concave mirror or a convex mirror, is reflected obliquely. The incident and reflected rays follow the laws of reflection at the point of incidence, point P, making equal angles with the principal axis and is shown below in the figure. Ray diagram for concave mirror. 1. When object is placed at far distance at infinite, image is formed at focus, which is inverted, real and diminished. 2. When object is placed beyond the center of curvature, image is formed between center of curvature and focus, which is inverted, real and diminished. 3. When object is placed at center of curvature, image is formed at center of curvature, which is inverted, real and equal. 4. When object is placed between center of curvature and focus, image is formed at beyond center of curvature, which is inverted, real and magnified. 5. When object is placed at focus of concave mirror, image is formed at infinite, which is real, inverted and highly magnified. 6. When object is placed between focus and pole of concave mirror, image is formed behind the mirror, which is virtual, erected and magnified. Ray diagram for convex mirror. Object is placed between infinity and the pole. Image is formed behind the mirror, which is virtual, erected and diminished. Uses of concave and convex mirror. Genius Education Classes, Katgar, Allahabad.